Hey guys. So this week, we've been talking about adding, subtracting, and multiplying polynomials. This week we're going to move on to dividing. And so when you talk about dividing polynomials, there's a special word for it, which is called factoring. And we're going to start by talking about factoring with a greatest common factor, which is going to be a little bit familiar to some stuff that you guys did, when you were in elementary school with factoring, except now you're including variables. So it's like a monomial or whatever that you're factoring. And what this ends up being is kind of like distributive property. So I'll talk about that too. So this first topic on IXL is ZZU. And so it says to find the greatest common factor. So let's just look at the coefficients, the 10 and the 6 for right now. When you were in elementary school and you were trying to find the greatest common factor for 10 and 6, you probably did something where you broke this down into factors. So this is the same as saying 2 times 5, which are both prime factors, right? And this is the same as saying 2 and 3. And then really you're kind of looking for things that are common, right? The idea of the greatest common factor. So I have a 2 in common on both sides, but that's it. So the greatest common factor here would be 2. So hopefully that seems familiar. Now we're going to do the same type of thing, but now we're going to include variables. So instead of just 10, now it's 10t to the third and 6t to the third. So really what that means, if I'm thinking about how this changes, I'm really saying that I'm doing 2 times 5, and then t to the third power is really saying t times t times t, right? Same thing here. So this is 2 and 3. But then if I do the t to the third, I need to look at it as t times t times t. So if I go through to find things at the bottom that match, I have a 2 here and a 2 here. Those match. And I have t, t, and t here, t, t, t here, and those match, which means that the things that I circled, the greatest common factor for this one is 2, and then t to the third power. So I'm really just looking for that same idea of what's the largest amount of things I can pull out of this, right? So let's move on and see. So now if I look at this one, I have z squared and 4z squared. So this is the same as saying z times z. This is the same as saying 2 times 2, right? And then z is z and z. So if I'm looking for matching things, I have a z here and a z here to match with this z and this z. So my greatest common factor for these is just z squared, which makes sense. If you look at this, there is no 4 in the first term to take out, right? There's no number, so I can't factor anything out. I can't divide anything out of it because it doesn't exist. All right, 6t squared and 4t. So it may not be the kind of thing that you need to write out all the way, right? You could say, well, if I'm looking at 6 and 4, the largest number I can divide out of that is 2. And then I have 2 t's here and 1 t here. So the most I can take out of both groups is 1 t. So 2t is my greatest common factor, which I could go through, right, and write this stuff down. So that would be 2, 3, t, t, and then 4t would be 2, 2, and t. So then if I'm looking for things in common, I have a 2 and a t, and that's all I have, 2t, right? So if you like to just be able to see it visually, this is how you would write it down if you need to show work. But some students really get to the point where it's very easy for them to just kind of see what the factor is. Especially like if you're good at reducing a fraction, for example, it's basically the same skill, is trying to identify what the largest amount is. So out of 6 and 3, I can definitely divide 3 out of both, right? And then I have 2 f's here and 3 f's here. So the largest amount I can take out of both groups is 2. I can take 2 out of both groups. For 8 and 6, I have 2 again, right? So I can divide 2 out of those evenly. And then it looks like I'm going to be able to take 2 t's out of both groups. So 8z to the third is 2 times 2 times 2 times z times z times z. And then 6z squared is 2 times 3 times z times z. And so if I'm just matching, I have a 2, I have a z, and I have another z. So 2z squared. All right, they also have you finding the greatest common factor when it's an expression like this, but this is really just saying with those 2 terms. So p to the 4th and 12. So what's a number I can divide out of both evenly? Well, I have p's here, but no p's here. And I have numbers here, but no numbers here. So really, the greatest common factor here, 1. I can't take anything out of it all the way, right? Except a 1's the only thing that will divide evenly out of both. Now, there's a couple of problems in here that had 3 different things. But if you look at this, you have 15, which is just 3 and 5. And then you have 5c to the 4th, which is a 5, and then c, 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 c. And then you have 1, which you can't divide anything out of 1 except 1, right? So that means that the greatest common factor here is 1 also. So sometimes you can't divide anything evenly out of all of it. If I look at this, my 2 terms are 5s to the 4th and negative 5s to the 3rd. Which the negative sign doesn't really matter, but I do need to make sure I understand that's part of the term, but it doesn't really change the factoring part. So this is 5 times, geez, it's funny how all my letters and numbers look alike. 5 times s times s times s times s. And then this is negative 5 times s times s times s times s. So if I'm looking, again, the negative sign doesn't really matter. I do have a 5 in both, and then I do have, oh, Miss Gray. Hold on. That's not supposed to be there. There's only 3 of them. So I have 3 here that I can match with these 3 here. So 5s to the 3rd. So the sign doesn't matter so much now, but later it's important to make sure you still see it, even if you're kind of ignoring it. This one's a little bit bigger, right? So if I'm looking between 12 and 6 and 18, I can divide, the biggest number I can divide out of all of them is 6. And then I have 2 J's in this group, 4 J's in this group, and 3 J's in this group. And so the largest amount I can take out of all of them is the smallest group, right? I can take J squared out of all 3. This one, same idea. So 22, 44, 11. So it looks like I can take 11 out of all 3. And then the largest amount I can take out of all of them is the smallest amount that I have, which is 8. I can take 8 out of 9 and 10. Greatest common factor when it's written out like this. So same kind of idea. I'm just looking at them as being separated. So I have 15, 45, and 30. So I can divide all of those by 15. And then I have 10Ks, 7Ks, and 2Ks. So I can only take 2Ks out of this term, which means I can only take 2Ks out of all of them. That's the biggest amount I can do. All right. Now we're finally moving on to a different IXL topic. So this is IXL topic ZZU, which is factoring out the greatest common factor. So it's not just finding the GCF, but it's also taking it out. And so really what this is reverse distributive property. It's almost like you're doing the distributive property backwards. So the first thing you have to do is figure out what is the greatest common factor. So for this problem, the greatest common factor, the largest number I can divide out is a 2. And then I have a K here and 3 Ks here, so I can take a K out of both groups. So this is the outside number when I have distributed property, and what I have to figure out is what's left inside the parentheses once I divide out 2K. So if I take 2K out of 2K to the third, so I had a 2, a K, and then 2 more Ks, right? So I took a 2K out, which left behind K squared. And then if I divide a 2K out here, I get 8 divided by 2, which is a positive 4. And I took the K out to the front. So what I wanted to point out is that in your mind, you can check this by doing the distributive property. If I think about multiplying this in, I have 2K to the third, and then 2K times 4 is 8K, which brings me back to what I started with. So you're doing the reverse of the distributive property. So this is your answer. You factored out 2K. You divided 2K out of this polynomial. Same idea here. So first I'm going to figure out the greatest common factor. And so that's going to be 2, right? I can divide out of 2, and then C, and I have 3 C's here and 2 C's here. So I'm going to take out C squared. And what it leaves behind here, if I have 2C to the third, and I take out 2C squared, I divide it out, it's going to leave 1C behind. And then I took out 2 here, I divided out a 2, so it's going to leave behind a 3. And I took out all C's to C squared, right? There was C squared, and I took it to the front. So now it looks like this. So if I wanted to check this, 2C squared, and then C minus 3, I can 2C to the third if I distribute, and then 2 times negative 3 is negative 6C squared, which is what I started with. So this is my answer. So it's pretty easy overall to check how it goes with this. Same thing here. So greatest common factor, first of all, is going to be 3. And then I have a Q here, but 3 Q's there, so I can take 1 Q out. So it's going to be 3Q on the outside. If I take out 3Q here, it's going to leave 2 Q's behind. And if I divide out 3Q here, 6 divided by 3 is going to leave behind a 2, and the Q went out to the front. So you can always check these by redistributing and seeing, does it turn back into what I started with? So greatest common factor on this one. So I have a 12 and an 18, so I can take out 6. And then I have 3 H's here and 1 H here, so I can take 1 H out to the front. And that's going to leave behind 12 divided by 6 is 2. H to the third, if I take out that 1, if I divide out 1 H, then I have H squared left over. And then plus 3 here, right? 6H times 3 is what's going to give me this 18H in the back. Here, I can take the 4 out to the front. So I have 4 and then a G. So once I do this, if I take 4G out to the front, I have 1G left in this group and then nothing left here, right? 4G came out to the front, which means I have nothing left in this group. And so remember that this whole thing of factoring is division. And so when I take it out, really I'm dividing it. 4G divided by 4G, and that's going to leave behind a 1. So this means if you take the whole thing out to the front, you left behind that 1. So you divided it out, which leaves 1 behind. Think about the multiplication too. If you're moving forward, 4G times G, and then 4G times negative 1 to get this negative 4G. So 30 and 18. So I can take 6 out, right? And then I have 1D in this group. So I can only take out 1. And if I divide 6 out of this 30, I have 5 with 4 D's left over. And then 18 divided by 6 is 3. All right. The last IXL topic for this week is HW8. And this one's a little bit different than the other two. This one's starting to talk about graphing and what happens when you graph a quadratic. So a quadratic function is basically when x has an exponent of 2. So when you have that squared term in there, that's when you're going to get this shape. So it won't be a straight line anymore. It's going to be this, which is called a parabola. And so we're going to, part of why we're learning how to factor is so we can find specific parts of the parabola. And the factored parts tell us where it crosses the x-axis here, which those are called roots. But we're not going to talk about that yet. There are a couple of things in this topic, though, HW8, that is going to want you to identify certain parts. So for example, because you have this bowl shape, you always have a minimum or a maximum point, one or the other. It depends on which way it's flipped. So this one has a max point right here. So it's either the smallest or the largest y value. And so this one here, the maximum for this, because it's the tallest point, right? So it's a max. The maximum here is at a 1. So it's always talking about where it is on the y-axis, the y value. The other part of it is that this point is called the vertex. And the vertex for this graph is at 1, 1. So just keep in mind that this y value here for the max comes from this number. All right, the other thing this graph has is it has an invisible line through the center. It's like an axis. It's called an axis of symmetry, which hopefully that makes sense why it's called an axis of symmetry, because realistically, this is where symmetrically, if you folded it in half, it would be. And the axis of symmetry is always the equation x equals some number. And it's whatever number it crosses on the x-axis. So for this one, since it crosses at 1, that means that my axis of symmetry, the equation for it is x equals 1. Okay, the other part that you'll need to know is where it crosses the y-axis. So this point here is called the y-intercept, because it's where it crosses this y-axis here. All right, let's look at a different graph and write down some stuff so you can see it again. So here I am. I'm going to switch over to red. My axis of symmetry is here, this red line, and it's the line x equals, and it crosses there at 2. So it's x equals 2. So this is my axis of symmetry. It looks like it crosses, it has a y-intercept of 0, because it crosses the y-axis at 0. And then it looks like it also has a vertex at this point here, which is 2, 8. And because of the way it's shaped, that means it has a max at 8, this number, right? So the maximum here is at 8. All right, same idea here. So this time my axis of symmetry is x equals -1. And then I have this time a minimum at -4. So it goes down to -4 as its lowest amount. And the vertex, that point there, is at -1, -4, right? Because the minimum here matches that vertex point. The y-intercept for this one is here. So the y-intercept is at -3. Okay, I think that's all of it. If you need help, then certainly you can stick around for some asynchronous times this week. Good luck. Let me know if you have questions.